So let's look at this first problem, and here we have to figure out what is theta, this angle in this triangle. And for this, if you have not learned the sine rule yet, that's okay. I'll just show it to you briefly here, but you don't have to learn it for the topic of this video. So the sine rule is basically sine angle A over side A is equal to sine angle B over sine B in any triangle. So what would this look like for our triangle? Well, here, for example, angle A could be theta, side A could be 35, and angle B can be 54, and side B, is 29. So if you plug this into a calculator, or if you just write it out over here like this, so sine theta over 35 is equal to sine 54 over 29. Can basically rewrite this, right? So you can turn it into theta is equal to sine minus 1 35 times sine 54 over 29. And if you put this into a calculator, and if you just put this into your calculator, right, you'll get an answer along the lines of 77.5 degrees. However, this is technically not the only answer you can have for this triangle. And this is where the ambiguous case of the sine rule comes in. See, if we, in this part of the triangle, if we just extend it a little, we can still see that it's still 29 centimeters this length, and it's still 54 degrees over here. So it's basically the same aspects of the triangle, but it's bigger size. And we can also see that the theta 2 and theta are now different angles. So how do we figure out this other possible angle for theta, which we'll call theta 2? Well, we can find this using the unit circle. And notice that because it will still fulfill the sine rule which we established earlier just for the sake of this question, it will still be equal to 35 sine 54 degrees over 29 centimeters. So let's now go and look at the unit circle. All right, so here we can once again see our unit circle. And if you remember, all students take calculus. We know in the first quadrant, all functions are positive. The second one, only sine is positive. In the third one, only tangent is positive. And in the last one, only cosine is positive. So let's look at this for a second. So the angle that the calculator gave us is 77.5 degrees. So where would this approximately plot? Well, it'll be over here, right? So we know that in this quadrant, sine is positive. And since we still want the angle, if put into sine, to give us this result over here, what we can do is look for another area where sine is positive, which is right near at the second quadrant, right? So we can draw them here. So at these angles, it fulfills this, and the triangle all makes sense. So how do we measure this angle? Well, since we know that the angle from the x-axis to each of the gray lines is exactly the same, and we know that this is 77.5, we can simply do 180 degrees minus 77.5, which is equal to 102.5 degrees. So what we've determined from using the unit circle is that this angle, 102.5 degrees, is as valid an answer as 77.5 degrees. And in the future, if you do problems like this, you might be expected to find both, and the unit circle will come in and help. Alright guys, so for the second problem, what we're given is sine x equals to minus a half. And we can actually use the unit circle over here to solve this problem. So what do we first notice about this what they've given us basically? We notice, of course, that the half is negative, right? So if we go back to the unit circle, we got to look at which quadrants the sine is negative. So in the first one, we know that all of them are positive. From all students take calculus, we know that it's also positive in the second quadrant. And we know that in the third and the fourth, they're negative, right? However, the question asks us, actually the question tells us that the x is between 180 and 270. and 270 is here. So even though sine is negative over here, our answer can only be in the third quadrant. So let's actually just draw a triangle using the values it has given us. So if we look at this triangle, right? All right, so now we have this triangle and we can actually put in these values right over here, right? So because we're assuming that it's a unit circle, the hypotenuse will be 1, but the ratio will still be the same. So instead of the opposite being -1 as it is here, it will simply be -1/2. And another thing we can realize about the equation that the question has given to us is that sine x equals 1/2 is one of our special angles. And when sine is equal to 1/2, we know that the angle within the function is probably something to do with 30 degrees. And in this case, because we've already noted that the function gives us a negative value, and the fourth quadrant is discounted, we can assume that this is 30 degrees, right? And it only has one possible answer because it has to be less than or equal to 270, and also it can be positive like over here or over here. So to calculate the actual value for x, the actual angle that will solve this problem, we basically have to count from the start. So we know this is 90 degrees, this is 90 degrees, and that is added to 30 degrees. So 30 degrees plus 2 times 90 degrees is equal to 210 degrees. So that is the answer, the value of x that is equal to -1/2 between the 180 degrees and 270 degrees, or basically in the third quadrant.
And so from our special triangle again, we can recall that this length here is going to be -√3 over 2, and that's important. So then we have cosine of x is going to be equal to -√3 over 2. And we know it's negative because it's on the left side of the y-axis. And so therefore, we know the tangent of x is equal to sine x over cosine x, which of course is then going to be equal to 1/2 divided by √3 over 2. And of course the 2's cancel like that. And then we of course are left with 1 over √3.